Today I'm going to present the paper with the title is Taxonomic and Functional Diversity Change is Scale Dependent. The reason I chose this paper because my current study focuses on evaluate the spatial and temporal of the taxonomic and functional diversity, but it's focus on different taxa. So I would say that the birth or observation is very attractive for many people, and the birds are one of the most taxa have the most abundant information. So if you are interested in bird observation, you may contribute well to science. So the biodiversity in the world is not a stable process. Everything is changing. So understand the changing of the biodiversity can help to evaluate the impact from human, or figure out the suitable planning. However, the local biodiversity change remains complex and contradictory, and quantitative assessment is lacking. So to evaluate biodiversity, we use biodiversity index, and the most common index is the taxonomic diversity or the alpha diversity. However, taxonomic diversity does not account for different ecological functional. Another index is a functional diversity. This index can help us to understand the process responsibility, and this information also crucial for conservation prioritization. So this study for conduct for birds because it's based on the fundamental of the breeding bird survey. It is an avian monitoring program, check the status and change of the bird population every year, and is the most comprehensive avian survey program in North American and maybe for global. So this program is very useful for evaluate biodiversity dynamic. And so the research question of this study is how taxonomics and functional diversity of birds change over 50 years across spatial scale. Okay, now let's see how they do study. For the bird data is collected from the North American Breeding Bird Survey. This program established in 1966, and they collect the bird information during the height of the avian breeding season along over 4,100 surveys routes across North America, and it follows standard monitoring protocol. So it's allow to study avian diversity pattern to time. Okay, so for taxonomic diversity is defined as how many species in sampling unit. The functional diversity is determined by how many functions the species in sampling unit perform. And in this study, they used body mass, the diet, and the foreign leash, and they also investigate the number of new species are colonize or the number of species disappear or extinct in local. So they do investigate in different scale from local to continental, United States, and global. So to evaluate the temporal change in diversity, they they calculate the taxonomist diversity for every year, and the change of the taxonomy modified as the slope of the long-term relationship between the taxonomy diversity and the time. So as you see here, if the slope equals 0, it means that there no change of taxonomic diversity, and if the slope is positive, it means the species really increase over time, or the slope is negative, it means the species richness decrease over time. They use the same protocol to evaluate the change of the taxonomy diversity colonization and the taxonomy diversity extinction, and for functional diversity as well. To evaluate the temporal beta diversity, they do investigate the temporal dissimilarity using this this formula, which compares the dissimilarity of the birth time year and the time 2016, and the change of the taxonomic dissimilarity or functional dissimilarity determined by the slope of the long-term relationship between the taxonomic dissimilarity, functional dissimilarity, and the time. They also consider other pattern of beta diversity, including the temporal turnover. The turnover pattern is the two side. Some species in other side were replaced by other species, and the next pattern means some species occur at one side but disappear at another side. So the formula to calculate the beta diversity in here, but I will not explain show detail, because you can see in the method of the study. So for temporal change, they also do temporal change in chest space. The chest space they investigate is the dietary leach by calculate the proportion of different type of food in the species diet, including invertebrate, fat fruit, the vertebrate, the pollen, carrion, seeds, and other plant material. Other chest space is a foreign leach, including the water below surface, understory, water around surface, terrestrial ground level, mid canopy, upper canopy, and area. And the last chest is the body mass. So we move on to the result of the study. The first is the taxonomic diversity. This figure shows us the taxonomic diversity and the relative taxonomic diversity change, or positive. It means that the species richness increase over time, and they are relative constant across spatial scale up to regional scale. And at the continental scale, the taxonomic diversity change increase, but the taxonomic diversity relative decrease. So this figure shows the pattern of taxonomic change. Each the color each cells present the value of the taxonomic change. The red color present the positive value as the increase in specificness, and the blue color indicates the decrease in specificness. And the number, the red number count the pixel which experience the increase of specific richness. The blue color represent the number of cells which decrease specificness. So we can see the local scale increase in taxonomy diversity with a significant regional variation. The northern, the northeastern United States show both decline and gain in taxonomic diversity at the local scale over decline in specific at the regional scale, and the southeastern US saw decline in taxonomy at local scale, intermediate scale, and regional scale. So the taxonomic diversity colonized and the taxonomic extinction were positive across time but decline toward cluster scale. The taxonomic colonization excess the taxonomic extinction at all but global scale. At global scale, the taxonomic colonization almost zero, but the taxonomic extinction higher than zero is result in decline in species or the negative taxonomic diversity change. The next result is the temporal dictionary, the last list and the turnover in taxonomy. In this figure, you can see the temporal lessness and turnover so opposite scaling characteristics. The taxonomic diversity turnover is positive but decline. The taxonomic diversity lessness is negative but increase, and both reach to zero at a global scale. It means there are no ecological bound to biodiversity. Next one is taxonomy and functional diversity. As you see in this figure, the scaling of functional diversity chain and taxonomy chains follow each other. Is clearly as local and intermediate scale, but functional diversity chain was increasingly accessed by taxonomic diversity chain towards cluster scale. It means that at very larger scale, increase or decline in specific are no longer associated with the addition or loss of unique ecological functions. The next one is a functional component. In here, you can see the chain of the body mass as from the local scale to at all scales the mean body mass increase, but continental scale. For that to niche in over the individual that and very heterogeneously across scale. The raptor increase in their relative prevalence at all spatial scale. The scale of bird feeding on plant matter increase at local and intermediate scale, but standard towards quarter scale. The insectivorous consistently decrease across all spatial scales. Uh, for the foreign lineage, the open water foreign saw little change locally but strong increase toward regional and continental scale. The graph foreign consistently decrease across all spatial scale. Most functional components show little or no temperature at regional and continental scale. For conclusion, this study investigates scale dependent of temperature in taxonomic diversity and functional diversity for almost 50 years. Record of avian assemblage. The average taxonomic and functional diversity increased along but global scale. Change in taxonomic excess change in functional diversity to larger scale. Cycling functional resilience assemblage temporal dissimilarity and terminal decline naturally increase with scale. The pattern of the functional change varies strongly among direct and foreign gills. The monitoring policy and conservation requires scale split framework. So there are some comment of this study. The shank is already presents a comprehensive dynamic burst diversity. But the weakness is I wonder about the global scale because the data is only for North American, so I have no idea why they consider it a global scale. Another thing is there are no data from 1966 to 1968, and there are some potential issue about the data bias. For example, is effects by weather condition, rely on the experience of observers. Some species are difficult to observe, like the lotterer, the crab, brush color, or the pelagic species. So that's all my presentation. I am ready for question. Thank you.